Hello, welcome back to this tutorial on STM32 programming. Now in this tutorial we're going to write a small program that's going to do the binary counting for us. So basically, as you can see here, I've already wired a circuit on to my breadboard here. So these 5 LEDs are all connected to the GPIO port A, so that is GPIOA. And then we also have 2 push buttons. Now these 2 push buttons, they will be reversing the counter. So now consider these 5 LEDs as 5 binary digit. So if I bring my calculator programmer here and enter 5 binary digit, and you're going to see that it has an equivalent decimal of 31. So what will happen here is when we start the counting, okay, so when the program starts, if I press one button, I'm going to start counting from 0 all the way to 31. And when I press the second button, we're then going to reverse the count. So from 31, counting down to 0. And when I press the 2 button, we're going to be counting with multiple of 2. So we're going to start by 1, then we go to 2, then we go to 4, then we go to 8 and 16, and we start again all over. Now the way the counting is going to be done is basically by writing specific values into the register, that is the GPIOA register. It's a 16-bit register where our LEDs are connected. So we're going to be turning specific bits, either a 1 or a 0, and that will be displaying, and that will be resulting either on the LED being on or off, and as a result we get a binary number. So that is what's going to happen. So stick around until the end of the video so that you don't miss how we're going to get this binary counter going. Now what you see here on Tinkercad is basically a representation of this breadboard circuit. Now it's much visible here than what it is here right now on my breadboard. So now the 5 LEDs are connected in a way that I've got the cathode of the LED connected to a resistor and going to ground. So all the resistors are 220 ohm and they are all connected to ground through the cathode of the LED. And the anode of the LEDs are all connected into this block of connection here. Now let's say this is my GPIOA register on my STM32. So this will be either pin 4, 5, 6 or whatever the case may be, where all these LEDs are connected. And right down here I've got also my 2 push buttons. Now the 2 push buttons are configured in a way that internally into the STM32 they will be pulled down to ground. So let's say this push button here is connected to pin 5 of GPIO-B and this one to pin 6. So when this one goes high, we then going to start counting from 0 to up. And when this one is released, this one goes down, then we start counting the other way. If both of them are pressed, then we're going to have that counting sequence simulation that I explained earlier. So this is how they are connected. This could be simulated, but unfortunately we don't have an STM32 into this Tinkercad program. So as you can see, the LEDs are on here. Okay, you can turn them on. You can basically just test your circuit, and you can also play with the push buttons and see as they are driving the ports to 5 volt. Okay, now enough of this. Now we need to start coding. And don't forget to give this tutorial a thumbs up, a like, that will be highly appreciated. And you can also subscribe to CMTEQ channel if you don't want to miss this kind of tutorial in the future. So now as you can see, this code here is for the previous tutorial. Now what we're going to do here, I'm going to just first clear these main functions here. Let's leave the while loop, because we are going to still make use of that while loop. Now we come here into the GPIO port configuration. Now as I've already said, all these LEDs are connected to GPIO port A, and my 2 push buttons are actually connected to GPIO port B. So we're going to modify the configuration to include more pins. As right now in the GPIO C configuration, which we have now to change to GPIO B. Okay, so this is going to be GPIO-B configuration. Now, the GPIO-C configuration was for the built-in button, that is this blue button, the push button. As you can see, this program is still working. And now the two external buttons here are now going to move from GPIO C to rather GPIO B. Now, as you can see here, this is the layout of this nuclear board. So the two push buttons, this one, the black wire is connected here. So that is basically D15, if I'm not mistaken. So that is D15 because it shifted a little bit right up. So that is D15 PB8, and the yellow wire is connected to D14, so that is PB9. So which means we need to change the pins here so that it can reflect our connection. So I'm just basically going to change this pin from 13 to 8, and I will use a logical OR operator to add another pin. So that will be GPIO pin number 9. So that will mean we are configuring pin 8 or pin 9. So they will both be configured. And then we need to change the GPIO initialization pull so that it can be a GPIO pull down, because that had no pull on that program. So this one then need to have a pull down. Now the reason there is a pull down, because the way the buttons are configured, as I said earlier, when I press the button, we're going to connect the pin to the 5 volt. So we're pulling up with a 10K here to connect it to 5 volt. Okay, so then we cannot leave the pin floating, right? So we have to pull it down so that it does not be influenced by either noise or anything of that matter. Okay, so that's the reason why we're putting a pull down there. Now we need to change the clock register here. That must be enabled. So this is from GPIO C, so we have to change that to B as well. And my initialization variable here also just need to change to B, right? Well, not that it matter, but just for that the context, let's make it to change to B. Then we are writing all that initialization settings into the GPIO port B. Right, the delay function will remain untouched. Okay, so then we move into the new configuration that is now for GPIOA. Now GPIOA, if I may bring that schematic again. Now, as I've said earlier, all my LEDs are connected to GPIOA. So I've used GPIO. So let's see where the first one is going. Let's see where this one is going. So this one is going to D7. D7 is PA8. Okay, so that's GPIO 8. Okay, and then it's going all the way since they are 5. So that basically means I'm coming from GPIO 4. Okay, here's GPIO 4 that is connected to A2. So if you check there, so the white and green wire here is going to A2 there, and that is coming to this pin here. So that will be pin 4. So I'm going all the way up. So that will be the least significant bit, LSB. And I'm coming all the way to the most significant bit, MSB, which is connected to GPIO 8. So basically what it means, I've got 5 pins there, and the 5 pins are GPIO 4, 5, 6, 7, and 8. So just like I've done here onto the port B configuration, I'm also going to use an OR operator to configure this GPIOA configuration. Just as we've used the OR operator here to configure either for pin 8 or 9, we're also going to use the same operator to configure for 5 pins on the port A. So to make matter easier for us, I'm going to copy like that, and I'm going to come here and then paste it, right? 6, 7, 8, right? So we don't need this other pin here because we already have our 1, 2, 3, 4, 5 pins. Okay, so I need another OR operand there, right? Okay, so now we've got all our pin configuration set up there. Then we just need to make sure that GPIOA clock is initialized. Okay, so nothing changed there. Now because these LEDs are connected on the output of the pin. So the GPIO is in output mode. So it is just important to add another configuration here. So I'm going to just copy this line of code here, change this to pull. So that will be the mode, and then I'm gonna say GPIO no pull. So we don't want any pull down or pull up for do no pull. So we don't want either a pull up or a pull down for our pin configuration as an output there. Okay, because we want to drive the LEDs properly. Right, so everything seems to be fine in the GPIOA configuration. Right, so then we can then head on into our main function too. So I'm just going to change here to GPIOB. Now, if I run this program, there's going to be a problem because there is no GPIOB function prototype into my main.h here. So I just need to come into my main.h here, okay, so that I can change these also to be GPIOB, because you need to follow track of all your function prototype so that you avoid problem. So now if I basically just run this program, there will not going to be any error, but I won't be getting anything because the main function is basically empty. Okay, so now the story here is very simple. We've got two push buttons. One button is responsible for initiating the count up, one is for initiating the countdown. So, but I want these buttons to be called with some readable name, right? Okay, so we know that we've set them here to be pin 8 and pin 9. So I want to give them humanly named. So I'm just going to write some preprocessor defines here. Okay, so preprocessor define. So the first one, I'm going to just say define button up. So this is for going up. So button up is GPIO pin 8. Then another preprocessor is going to be define button down, and that is GPIO pin 9. Right. Two more. That is now going to be for the state, either low or high. Okay. So that's going to be define low. So what is low? We know that it's GPIO pin reset. So when we reset a pin, we set it low. Then another one is going to be define high. So high is GPIO pin set, right? Correct. So there is a GPIO pin set and GPIO pin reset. Now I need to initialize the variable for the counter. We know that when we're counting up, we're starting from 0, and when we're counting down, we're starting from the full 31. So this will be then variables initialization. Correct. So variable initialization, they will be unsigned integer for my variable. So that's going to be count up is equal to 0, and another one unsigned integer, and this is now going to be countdown. So the countdown variable is going to be, we're going to be counting down from the full set of full binary number, which is in decimal, it's 31, right? And we now just need to specify it in hexadecimal. So that's going to be 0x1f, something like that. Okay, so now we are good to go here. So we can then come into our main function while loop here, our infinite loop. Now imagine the program have been loaded, nothing is being pressed. So what must the program do? We need to define that state, because it's a state. Pressing is one state, pressing this one is another state, pressing both is also a state. Now what if they are not being pressed? It's a state. So what are you going to do in that state? So we're going to write an if statement here. Okay, then I just open my bracket. Now inside the if statement, what am I going to put in there? I'm going to read the conditions of the button. So I'm going to say if both buttons are reading 0 if they are not being pressed. So I'm gonna call the HAL library that do the reading for me. So that will be HAL GPIO. I think it's read pin, if I'm not mistaken. Okay, GPIO read pin. Right, now this function here is asking for parameters. So what are the parameters of this function? We can clearly see here you want the port and the port number, the pin number that we are using. So we are actually reading from port B. So right away I can say GPIO B. GPIO B and what? Pin 8. Pin 8, I already defined it there to be button up. So I'm just going to write button up. Because I know if I'm reading button up, I'm reading from GPIO pin 8. Now for me to read, if it's not being pressed, I need to negate this expression, the reading. So it must be a not. So I just put that exclamation marks there. That means I'm negating that reading. Okay, and I need to also check the condition of the other button. So that will be the end there. So what I'm going to do here is, since I'm calling the same function, I'm just going to copy it just to make life easier, and I'll paste it there. Then I'm just going to change here from button up to button down. Button down, something like that. So now I'm reading, if I'm reading both of them to be equal to 0, as they are already being pulled down. So basically they're going to be 0, correct? So if that's the case, what do I do here? Now I want to do something here. I want to flash the LEDs. If I'm not doing anything, I want to flash the LEDs. So I want to say flash all LEDs. So I want to flash all these LEDs at least once. When the program starts, I just flash it once when nothing is happening, right? And in order to do that, I need to create a condition, because I don't want to be flashing them forever. It's going to confuse the situation, because if I'm not doing anything, I don't want the LED just flashing. But when I boot up, I just want to flash the LEDs, because I know I'm putting into that condition, correct? So in order to achieve that, what I'm going to do, I'm going to call a while loop. Okay, so another while loop. Now, but this while loop is not going to be like this one here, which is an infinite while loop. This one here got a lifespan, so it's going to expire. So I'm going to get a condition here. So I'm going to just call j is less than 2. So long as j is less than 2, I want this while loop here to just execute something for me. But I haven't declared the variable j yet. So I need to come here and initialize int j is equal to 0. So j is now equal to 0, so we are now good to go. Now since j is equal to 0, well, j is less than 2. That is true. So I'm going to execute something. So what am I going to execute? I'm going to write something into all this pin. So what I'm going to do is I'm going to say HAL GPIO write pin. Now the GPIO write pin function actually set or reset a specific bits in the register. Right, you've seen in the previous tutorial here, when we were saying GPIO write pin, we took GPIOA and we set pin 5 and then we wrote a reset, so it set it to 0. So this is the bit that we are targeting, and this is what we're writing. Now here it's gonna be the same thing. We are going to be using GPIOA, okay, and then I'm gonna put a comma there, and then we are going to be setting them high. Okay, so I've already got high declare here as a GPIO pin set, but we need to write a value here. The value that we're going to write there must target all these bits where the LEDs are connected. So if it was only one LED, we could just say GPIO pin 4, right? Just like we were doing here, pin 5. But now we've got a lot of pins, so we have to write a value that is going to be a representation of that register. Now, if you see here, this is one example of a register table. You can see it's 16-bit from 0 to 15. Now, assuming that our LEDs are connected to 4, 5, 6, 7, and 8, that means if we are targeting these pins here, we need to write a specific value that is going to be a representation of singling out these bits to either write them a low or write them a high. So when I take my calculator, program a calculator here, and I go to hexadecimal there, and I write 1F8. This is what I'm getting. But this is what I'm getting. It is targeting specific pin right on the center of the register. And that will be an exact representation of these bits here that I'm targeting. They are almost in the center of the register. So I'm going to write 1 in hexadecimal. So 0x1F8. So this is the value that I'm writing or I'm selecting to target in a 16-bit register, and I'm turning it high. So this 1F8 value is the bit that I'm targeting into that 16-bit register to write a high. Now, after writing a high, I can then delay. Okay, I'm going to just delay for a moment here. Arbitrary delay number. Okay, after delaying, then I need to reset them. So since I'm going to reset the same pin, I'm just going to copy them and then just change here to a reset. And that is to write a low. As we already defined in the processor, low is for pin reset. Now, after turning them off, I can then delay again for a moment. So I'm going to delay again. Another delay. And what am I going to do? I then need to increment my variable. So the variable j must then be incremented. After incrementing the variable j, I'm going to come back and do it again until j is no longer less than 2. Then I exit the loop. After exiting the loop, then I need to sit somewhere here and wait when something is going to happen there. Okay, so now remember, I want to ensure that they stays off. Okay, so they have to stay off. So for me to ensure that they have to stay off, I just need to take this line of code and just paste it here. So this will mean I'm actually ensuring that once I'm exiting the loop, the conditions of the LEDs are going to stay off, because I'm no longer inside the loop and I'm waiting for either to start counting up or to start counting down. Now I'm going to just build this program and write it in. Okay, we've got okay, there are no error, but there is a warning here, unused variable flag. Okay, we are not using the flag, so that was for the previous program, so that's fine. So we just remove it. Now I can just write it into the chip, and then we see what is going to happen. So let's just write it in. All right, we're launching the debugger. So now we are going to be writing the code in. Okay, so now the program is running. Nothing is happening because obviously the buttons are not being pressed, but we did run through a loop. So to see that, I have to reset here. So if I reset, you can see we're flashing twice. Okay, so when I reset, we're flashing all the pins twice. So we're flashing all the LEDs twice, and then we are waiting. So basically, we're just getting out of this while loop, and we're just putting them off again, and then we're staying there. So now we are waiting. So what are we waiting? We're waiting for another action. So we now need to wait for these other conditions. Since these conditions, we've checked it, now we need to now check for the condition when the button is pressed, or when this button is pressed, or when both are being pressed. Now I'm going to stop this tutorial here, and I'm going to continue with part 2 of this tutorial so we can finish it off. Okay, so stay tuned for the next tutorial, part 2.